Hello and thank you for watching my video. My name is Astrid Krasniqi. I'm CCNA and CCNP certified instructor. On this video I will be demonstrating you how to configure Rapid per VLAN Spanning Tree Plus, PortFast and BPDU guard. For this lab we're going to need 3 switches and 2 PCs. I'm using 3 physical switches, 2 layer 2 switches and 1 layer 3 switch, and 2 virtual PCs, PCA and PCC. You can pause this video and have a look, write down the topology that we're going to be using. These are the connections. PCA is connected to switch 1, FA06. PCC is connected to switch 3, FA018. Switches, switch 1 and switch 2, FA07. Switch 1 and switch 3, FA013. Switch 3 and switch 2, 10, FA010. Okay, so this is a part of the CCNA semester 3. Chapter 2, a spanning tree. Okay. Now, this is a connection to my PCs. I've got 2 PCs, PCA and PCC here, and I've got connection to my access server. So if this is my access server, switch show session. I've got 3 sessions. Session 1 for switch 1, session 2, switch 2, and switch 3. They're all been reset and erased all the startup configuration. So if I go to switch 1, okay, I can see that there's no configuration, so no there. And I go to switch 2, no there as well. Once then switch 3 as well, no. Okay, on this lab, first thing we need to do is initialize and reload the switches as necessary, so we did that. Configure basic settings for the switch. Okay, so I open the notepad. I'm going to write down all my configuration, the basic settings for all switches. So all switches. The startup configuration. So enable, secret, class, no IP domain lookup, service, password, encryption. What else do we need to do? The startup configuration. Banner, MOTD, authorized users only. Okay, so next we need to go to line console 0, password Cisco, login sync, and an exec timeout 00. Line BTY 0 to 4, password Cisco, login, and copy running config to startup config. Okay. So I'm just going to copy and paste all this to my switches. So let me just put the name as well. So name my switches. So host name S1 here. That's for S1. So right click, highlight, copy. I'm gonna go to my switch 1. So Control Shift 6X1 to go to switch 1. Enable config T, and just right click. You can see that enable secret is fine. Then we change the name from switch hostname S1 there. Okay. Control Shift 6X, and then I go to switch 2. This is my switch 2, so enable config T, and then I go to my notepad and just change my host name to 2 here. Right. Copy and paste that. Okay, excellent. Now I Control Shift 6 to switch 3, enable config T, and then go to notepad, change the host name to S3. Okay, highlight all that and copy and paste. Okay, paste on the just right click, yeah, that's all we have to do. Right, we did that. Configure basic switch settings on each switch, configure user VLAN 10, native VLAN 99, and trunks on and IP addresses on each of the switches. Okay, so for all the switches, again, all, I'm gonna do I don't need to do for all of them. I can something called VTP was going to take care of it, but let's just do it for all of them. VLAN 10 and name users. VLAN 99 name management. Okay, so I'll highlight all this and copy it to my switches. So I'll write to switch 1, config T, go to switch 2, config T, and then switch 3. Okay, I'm going to verify it only in the switch 3, but I'm presuming they're exactly the same as on switch 1 and 2. No waste our time. Show VLAN brief. There, the 2 VLANs are recreated. Okay, let's just do it quickly on VLAN, other VLANs. Do show VLAN brief. VLAN brief. Yep. Here we don't have 99. Okay. Let's create. Okay. Do show VLAN brief. Yep, that's 99 there. And do show VLAN brief here as well. And we don't have 99 here as well. Okay, let's just create it. Do show VLAN brief. Okay, maybe because we didn't exit. Until you exit, the VLANs they don't take effect. So that's why we didn't see 99, but we saw 10. We're not copy and pasting all of them the same. But until you exit, you're not going to see it. In S3, I did exit. Okay, so we did configure VLAN 10, 99, and add trunks for all the switches. So we're going to do some trunking here. So this information is for switch 1. So S1. I'll do it in the range. So interface range FA07 and comma FA13 switch port mode trunk, and what else will I do? No, that's it for switch 1. Now switch 2 is a bit more challenging because switch 2 is a layer 3 switch, as you can see there. So it does need one more command. Switch port trunk encapsulation .1q. Okay, and this is switch 2, and switch 3 is this layer 2, so we can just copy this. Okay, now switch 1 has FA07 and 13, that's correct. Switch 2 have 7 and 10, so 7 and 10, and switch 3 has 10 and 13, so this is switch 3, and it's 10 and 13. One more thing, we need to make sure the native VLAN is 99. So it says here native VLAN 99. So switch port trunk native VLAN 99 on all the switches, all 3 switches. Okay, that's it, done. So I'm just going to copy and paste all this on my switches. So copy this, go to switch 1, done. Go again to my notepad, copy the switch 2 information. Already is inconsistent because it's a mismatch, the native VLAN mismatch. But once I fix all that on all 3 switches, it's going to be fine. The best thing to do is to shut down the port first, do the configuration, and then no shut down the port. Config T. Okay. Now to make sure, so I'll go to switch 1 and in here show interface trunk. Okay, see, first it's blocked it and then it unblocked it. Spanning tree unblock, consistent port, port consistency is restored because of the native VLAN. Yeah, it did match now, so it's fine. So if I go to see, same thing for switch 2, unblocking port, port consistency restored. Show interface trunk. So if you do one of the switches, don't get stuck and say, okay, well, it's not working, what do I do, I got this problem. Just do all the switches and then see if it fixes. The problem is, the best thing is, well, like I said, shut down the ports first and then no shutdown. Okay, so in port 3, switch 3, show interface trunk, and I can see all my two interfaces, 10 and 13 on switch 3. So if I go to switch 3, 10 and 13. Okay, give an IP address and test with ping. Okay, so each switch will get an IP address. So on port 99, VLAN 99. Switch 1, interface VLAN 99, give an IP address, so IP address 192, as it says up there, you can see it up there, 192.168.99.1 and /24, no shutdown. Right, I'll copy this for all 3 switches. So I have switch 2 here, and then switch 3. Switch 2 is going to have .2 in the end, and then switch 3, .3 in the end, as you can see there. Copy this info for switch 1. And then paste it, and then do the same for switch 2. Config T, paste it, and then copy the switch 3 information. Okay, done. Now if I go to switch 1, I should be able to ping. Switch 1 should be able to ping switch 2 and switch 3. So I'm going to ping 192.168.99.2 and 192.168.99.3, and hopefully I get some results. So ping 192.168.99.2. This is switch 2. Yep, 4 exclamation mark. We lost 1 because of our request, and then 99.3. Excellent. And then I will go to switch 2 and ping from switch 2 to switch 3, and if that's successful, then everything is working. All 3 are working. Yep, that's successful as well. Okay, so we did configure VLANs, VLAN 10, VLAN 99, and then VLAN 99 is our management and the native VLAN. We configured trunks between these 3 switches, and configured IP addresses, and we did test it with ping. Now these PCs we need to configure, verify connectivity between PCs. These PCs are going to be on VLAN 10, so let me try right here, VLAN 10. So I need to put them on the VLAN 10 as well. Okay. Well, the PCs they're not going to know that, so let me just write it here. This port is going to be on the VLAN 10, not the PC. This port 6 on this switch 1, and port 18 on switch. So PCs don't know what VLANs they belong. Okay, but we need to configure the PCs first. So that's my PCA, and that is my PCC. So I need to configure an IP address, control panel, network and internet, network and sharing, change adapter settings, and right click on the adapter properties, select TCP IPv4, and give an IP address 192.168.0.2. Let me just see. That's the IP address, /24. Great. Now I don't need a gateway because we're not going to use a gateway. And the same thing I did for PC C here as well, but we can go and check it. Control panel, network and internet, network and sharing, change adapter settings. Okay, .3. So when if you compare, that's fine. Okay there. Now I'm gonna try and ping from PC1A to PCC. So CMD ping 192.168.0.3. I got a reply. Excellent. Now what I'm going to do is I'm going to put them on the correct VLAN. But first, before I do both of them, we're going to see that first it doesn't work until we add them both on the VLAN 10, for example. So switch 1, the config is like this. Interface FA06 switchboard mode access switchboard access VLAN 10. Not shut down. I think we should have shut down all the ports first to start with. Okay, that's it. And the same config for, similar config for switch 3, but switch 3 has port 18, so I need to go change this to port 18. Okay, so I'll do this first on the switch 1. So copy, go to switch 1. Well, no, not switch 2. It's good that wasn't not that. Okay, so change it to switch 1, config 2, and then show spanning tree just to see that when the port starts forwarding. Switch VLAN 10, still listening mode. See, because the spanning tree is going to treat this port as, because we didn't tell that is a PC connected to it, so it's going to treat it as a switch connected to it. So first it's going to go to, we saw it, listening, port 6 is listening. Now it's going to learning, find out, okay, well I'm going to quite quickly go to forwarding. Yeah, now it's forwarding. Since it's forwarding, I have to go to this PC and I'll run a continuous ping. So ping, now it's not gonna work until we paste the switch 3 configuration, right? So we see request time out there, destination host unreachable. Okay, we're gonna go there and copy this to the switch 3. Config D and paste it there. Now show spanning tree VLAN 10. This is going to be first 18. See, 1880. It's listening. Right. Let me bring that PC as well. Oh, I should have used continuous pick. So -2. Now it's working. See, we just missed one. It wasn't working. Now it's forwarding. So if it's on the different VLAN, it doesn't work because PCA was on VLAN 10. We just put in VLAN 10, and then PCC was in VLAN 1 by default, and then until we put it back, it wasn't working. So we can demonstrate. I'll try and demonstrate all this again. Just put this like this, so we can see both. Right. Now that's PCA pinging PCC, right? It's working. But when I go to that interface FA018, where PCC is, and I say switchboard access VLAN 1, right? When it's on VLAN 1, it stops working, right? Request timeout. Because they have to be on the same VLAN for it to work. Or you need a layer 3 device, like a router, to do the inter VLAN routing. But let me put it on VLAN 10 because that's not the... Okay, so once we put on the VLAN 10 and the spanning tree has found out that there's no loop, VLAN 10. See, now it's listening. Still not working. Then it's going to work. Once the spanning tree finds there is no loop, so learning now. Learning still not working. Learning, still not working. Learning, and now it's working. You can see the forwarding there. Now you can see it is working there. Okay, so the spanning tree stops us from making sure, the spanning tree is making sure that there's no loop. If there's a loop, spanning tree is not going to allow it. So we're waiting for that timers. I mean, this PC waited quite a long time. You can see waited quite a bit there. Each of these is about 2 seconds. Yeah. Okay. Verify connectivity between PCA and PCC. Okay, I think we did that. So we can check it again. Yep, we can ping PCA, can ping PCC. Excellent. Next, what do we have to do? Determine the current route bridge, right? So if I go to, we did it for VLAN 10, yeah? So show VLAN, show spanning tree, VLAN 10. this information here is information about the switch where we're running this command. Information up here is information about the switch, the root bridge. So all I'm interested in is the address. Let's look at the address first of each switch, right? So that address I'm interested on. So the MAC address. So S1 MAC is this, right? S2 show span VLAN 10. No, sorry. 10. The MAC address of S2 is this, right? So let me write it down. And S3 show span VLAN 10. The MAC address of S3 is this. Right. So this is 2, this is 3. Right. The first thing that they're going to look at these switches, they're going to look at the priority. The priority is 32768. That's the default priority if you don't change it. So all of them, the priority is going to be the same. So the priority 32768 plus the MAC address. So if the priority is same, we have a look at the MAC address. Because we haven't changed anything, they're brand new switches, the priority is going to be for all of them 32768 plus the system exit extended ID, and then adds the 32778 on this instance. Now the priority is the same for all three. So they look at the MAC address. The lower on the MAC address, better. Since they start looking from this digit, from the first digit, right? All zeros, move to the next digit, all zeros, fine. Third digit, 1, 1, 2 here. So switch 3 loses right away. And then we move to the fourth digit, D and C. C is better than D, it's lower, so C is the root bridge. So switch 2 is a root. Because of this MAC address, C is better than D. So if I go to switch 2 here, show spanning tree for VLAN 10, it's going to be the same for all the VLANs. You can see that this says this bridge is a root bridge, or is a root, right? It's got this is a priority, it's the same for all of them, 32768 plus 10. And then the MAC address is the same. You can look at the MAC address of the root bridge and the switch 2 MAC address is the same. And when you can see other switches, for example, show span, same for all the VLANs, it can be 99, same. Now you can see all of the switches, they report the root bridges up here, the MAC address, and how much does it cost to get there, to get to the root bridge. Now all the switches, they are giving out the switches 2 MAC address as the root bridge. So 001C, 57D5, 8700, you can compare that. And how much it costs to get there. So for example, if the link is 100 Mbps, it's 19, right? If the link is 1000 Mbps or gigabit, it's 4, or if the link is 10,000 Mbps, then it's 2. This cost, you can change it. We saw it on the other video that we could change it. Okay, so switch 2 is our root bridge, right? So we can write it here somewhere. Root. Now, which port is it? This is going to be the fastest port. For switch 1, for example, FA07 is going to be the root port. Let's go and have a look. Yeah, FA07 is a root port. Because it's better going this way than this way, right? So I'm going to put it down this as a root port. Yeah. Okay. Now, which one is for switch 3? So if I go to switch 3 now, show span VLAN 10. For switch 3 is 10. The port 10 is the root port. So if I copy this, port 10 is my root port. Port 7 here is the root port. Port 10 on this side. So which one is going to fight? Which one is going to lose? Switch 1 and switch 3. Let's have a look. Which one is blocking? Well, I can see the switch 3 is blocking. Port 13 is blocking. So this one, I'll put in red since it's blocking. Yeah, the reason is because first thing they're going to compare from this port to the root bridge is it which one is faster, this way or this way. Well, it's the same, exactly the same. And then next thing they're going to compare is the priority. Priority is the same, so they're going to compare the MAC address. If you look at the MAC address, switch 1 has got a better MAC address than switch 3. That's why this port 1 and this is blocked. Okay. Okay, let's move on. Says configure primary and secondary root bridge for all existing VLANs. VLAN 10 primary is a switch 1. So if I go to configure switch 1, so S1 spanning tree VLAN 10 root primary, and then switch 2 is going to be the secondary. So S2, again same thing, I can just copy that, and in the end secondary. Okay, so copy this to switch 1. Okay, and then I'll copy this switch 2 or switch 3? Switch 2. Okay, go to switch 2. Yeah, now if I go to switch 1, show spanning tree for VLAN 10, you can see that it says now this bridge is the root bridge. So switch 1 is a root bridge for VLAN 10 because the priority is 24586, which is 24576 plus 10. 24576 plus 10. What about VLAN 99? Did you change that? No. For VLAN 99, we still doesn't say this switch is the root bridge. VLAN 10, yes, because we did change it. Okay, so the command was spanning tree VLAN 10, and then root. You can say root primary, or you can make a secondary. Right? There's another way to do it. You can do it with the priority. Yeah, you can type priority with this command, and then give it a name, number. So now the priority has to be in increments of 4096. So if I put 2, for example, does it work? No. It says bridge priority must be in increments of 4096. Allowed values is giving you the values that are allowed. Right? So if you don't remember, you can just give a number and then we'll give you these digits that are allowed. Okay. So for our VLAN 99, the primary should be switch 3 and secondary switch 2. So we can do it this way as well. Okay, so switch 3 is going to be our primary for VLAN 99. So spanning tree VLAN 99 priority, and then just give it a priority. So for example, I don't know, that's 4096. That's going to be it. And then the switch 2 is going to be our secondary. So the value for the secondary, I'm going to pick, I don't know, let's pick that one. There we go. This is going to be switch 2. So I got to copy this to switch 3. Ctrl T. Done. And I copy this to switch 2. Okay. And if I do show VLAN, sorry, not show VLAN, show spanning tree for all the VLANs. VLAN 1 we didn't change anything. So VLAN 1 is still, still the root bridge because the priority is the same and it's got the lowest MAC address. So switch 2 is the root bridge. For VLAN 10 is not the root bridge. The root bridge has got 24586. Okay, so which was the first configuration that we did here, the switch 1. And VLAN 99 the root bridge is 4195. So 4096 that we did there plus 99. Okay, so here for example, so switch 1 is the root for VLAN 10, and this one is the root for VLAN 99. This way is very good because it's like kind of load balancing. For VLAN 10, I'm going to write it in red. Which one is blocking, I'm going to write it in red. And for VLAN 99, whatever is blocking it, I'm going to write it, I don't know, let's write it in green. I don't know if you can see it. Okay, so let's see who's blocking. So show spanning tree VLAN, sorry, 99. So it's not blocking for VLAN 99. What about VLAN 10? No blocking either. Okay, let's go to switch 3 here. Do show spanning tree VLAN 10. So for VLAN 10, port 10 is blocking, right? So VLAN 10 in red, this port is blocking. VLAN 99, if I go to switch 1, to show span VLAN 99. So VLAN 99, port 7 is blocking, right? So this port is blocking. I'll put this in a green asset. Okay, so the reason why you can do this is you can see you have a kind of like a load balancing. For VLAN 99, this port is blocking. For VLAN 10, this port is blocking. So at one stage, you will never have only one port always blocking for every VLAN. So that gives you, per VLAN spanning tree, gives you that benefit. Change the layer topology to layer 2 topology and examine the convergence on PVST. Okay, so we're going to take VLAN 10 for VLAN 10, and I'm going to go and block that port, right? So no, yeah, shut down that port, and that port should come green, right? So if I go to switch 3 and show span VLAN 10, so you can see for VLAN 10 the port 10 is blocking, yeah? So port 10 is blocking, this for VLAN 10 this port is blocking, and this port, the root port, is port 13. So this port is the root. So anything that has information to the root bridge, I go this way. Now I'm going to shut down that port, right? So I don't know, let's put this one like that. I'll shut down that port. This port should come up, right? But before we do that, let's just see like times. How long does it take? Config D, or end first. Debug spanning tree events, and then I'll shut down the root port. So root port was what? 13. So interface FA013 shut down, right? Now you can see that for VLAN 10, for example, its new root port, it's 10. It's saying it's 10. This is the new root port to get the root port. And the cost, you can see the cost, it says 38, because there will be 19 here plus 19, that's 38. Okay. So interface change down. We send the topology change. So notice we send it on the port 10. We send the notification to the root bridge that this port has gone down. And then port 10 went to listening first. So it wanted listening, then it went to learning, and now it's forwarding, right? Well, I want to see the times here, right? From the time we shut down to the time, from the time we've noticed a new root port, 50, 28, up to when we went forwarding, 50, 58. So it took us 30 seconds from the time we went from we found out that the port has shut down to the port up 30 seconds. Okay, so no, I got the same interface FA0, what was it? The root port, 13, FA0 13, no shot. How long does it come back up? Right, let's have a look. Now, from the time we found out that 0.5 has gone up to 0.9, it changed up. So from when it's shutting down and when you swap into another port, it hasn't gone up yet, right? We're still learning. So 0.5, the port has been no shut down, and we're still waiting. Now 37, we are moved forward, right? So 32 seconds it took. Okay. The next one, configure a rapid spanning tree. Now to configure the rapid spanning tree, the commands is, we're gonna do it for all switches. So spanning tree, so this is for S1. So spanning tree mode rapid PVST. Right, this is gonna be for all switches. So all switches, they have to have the same spanning tree mode that you're gonna configure. So we're gonna configure rapid spanning tree for all the switches. So let me just go to switch on, paste that, go to switch 2, paste that, and then go to switch 3 and paste that. Okay. Now, important thing is, here are the proposals and agreements are coming. Quite a lot of proposals. Okay, once we finished, everything has finalized here, the rapid spanning tree, we'll do the same thing what we did earlier. So we're gonna shut down, this port is gonna be the root port for VLAN 10, and we're gonna shut down and see how long this port is gonna take over. Okay, what we're gonna see is now, if we shut port 10, how long before port 13 will become, if we shut port 13, how long port 10 will become our new root bridge. So if we shut this port, this is port for VLAN 10, is the root port. If we shut this port, how long will this port take over? So P interface FA013, shut down. Okay, look, right away, we shut down in 43. 43 is being chosen. FA10 is a new root port. Didn't have to go through the waiting timers. So, okay. If I do show span VLAN 10 again, you can see the port 10 is already forwarding right away. Port 18 is going through the learning stages, learning and listening stages, right? Because it's asking, they're sending the proposal, agreement, proposal, but is waiting for that agreement. There's nothing coming on. That's why he's having to wait through this. Is reverting back to old ways of listening, learning, because there's no agreement happening there. But port 10 is already gone right away onto a root port. Okay, next. Right, the next one was down here, to configure PortFast and BPDU guard on access ports. So access port, for example, if you look, an access port was FA06 and FA018. So we need to configure PortFast on those two ports. So on the first, it's on switch 1. So exit. So for example, let's just see it. Show span VLAN 10. Right, this port here, port 06. Right, so if I do config T interface FA06, right, at the same time, I want to start pinging. So if I go to the PC, this is my PC that I was using. I'm gonna do a continuous ping again, right? Keep pinging. And when I do shutdown, obviously we're gonna shut down. It's not gonna work, right? So there's no ping happening because I'll shut down the port. When I do no shutdown, now how long before my pings they start coming again? It's quite a long time. Still, not as long as common Spanish tree or PVST Spanish tree, but this is a long time. I did no shutdown. The port has stayed up. If I do show span VLAN 10, port is on VLAN 10. See, the port is still learning. So first it went to listening, now it's learning, and then it's gonna go to forwarding. Now it's forwarding. So now I should start seeing some replies, which I do. Now you don't want to, even with a rapid per VLAN spanning tree, it will revert back to just per VLAN spanning tree, because through the proposal agreement, there's no agreement, it's gonna wait through listening and learning states. Right, for that reason, this port, we want to make sure that it's immediately switched on. So spanning tree, PortFast. That's it, that's the command. Now we get a warning that says, okay, well, make sure that there's no switches connected to it, but it will not be, if it's in trunk, only when it's non-trunking mode it will be configured as PortFast. Okay, excellent. So when I do shutdown again, this time, you can see there it will stop, my pings will start. Request timeout. But when I do no shutdown, how long do I have to wait now? No shut. As soon as the port goes up, yep, up, replies. So it didn't have to wait for the, so when I do shut, stops. As soon as the physically port turns back up, the port is able to send and receive data. So no shut. As soon as you see up here, like this here before, then they should see replies here. Up, well, replies. Okay, and then this port you should never have, because of that message earlier, you should not connect like switches, concentrators, hubs and bridges and so on. We have to protect them. So spanning tree, BPDU guard, BPDU guard, enable. So with this, we are saying, okay, well, we're never going to connect a switch to it. If we connect a switch to it, this port will be error disabled. Okay, that's it. Thank you very much for watching my video. This is a long video, but it's quite interesting, some interesting stuff here. This was Astrid Krasniqi showing you or demonstrating you how to configure rapid per VLAN spanning tree plus PortFast and BPDU guard. Thank you very much, and see you in future videos.